Welcome, everyone, to today's masterclass. Go ahead and grab a seat, get your notebooks out, and let's really focus in because today we are undertaking a critical explainer. Now, this has a dual purpose for us. On one hand, yes, this is your rigorous preparation for the UGC NET exam, specifically Paper 1, Unit 9. We're going to make absolutely sure you have the exact facts you need to ace that section. But, on a much deeper, much more important level, we are going to unpack the invisible biological warfare that is quite literally taking place in our environment right now. We're going to look at the exact mechanisms by which the air we breathe and the water we drink can turn against our own biology. It is fascinating, it is honestly a little terrifying, and it is absolutely essential knowledge. Okay, let's just do a really quick flyby of the syllabus today so you know where we're headed. First, an introduction to pollutants and health. Next, airborne threats and respiratory risks. Then we'll dive into water contaminants and heavy metals. And finally, we'll wrap up with our exam revision and conclusion. All right, let's jump right into Module 1, Introduction to Pollutants and Health. So, to truly grasp this material, I need you all to stop thinking like passive students for a minute and start thinking like medical detectives. We have to understand the actual pathology of our environment, because when an unnatural element enters the human biological system, there is always a consequence. Right? Our core goal today is to map the pollutant directly to its pathology. Look, memorizing these relationships isn't just some annoying hurdle you have to jump over to pass a test. I want you to understand precisely how our bodies react to different environmental intrusions. When you understand the why and the how, the memorization basically does itself. You aren't just memorizing random words, you are understanding a literal biological chain of events.
Which brings us to Module 2, Airborne Threats and Respiratory Risks.
Now, think about this. Every single time you take a breath in a polluted city, you are unknowingly inviting microscopic invaders into the most delicate tissues of your body. This setup right here brilliantly illustrates the two primary methods of attack that our lungs face. On the left side, we have physical damage, which is represented by PM 2.5. And over on the right, we have chemical damage, represented by carbon monoxide or CO. For the exam, and just for your own baseline understanding, it is absolutely vital that you know the difference between particles physically clogging and scarring your body versus invisible gases chemically hijacking your cellular systems. Let's actually geek out over the biology of the physical damage first. PM 2.5. This stands for particulate matter that is 2.5 micrometers or smaller in diameter. To put that completely mind-boggling scale into perspective, that is a fraction of the width of a single human hair. Because these particles are so incredibly tiny, they just don't get filtered out by your nose or your throat. They bypass all our natural defenses and travel all the way down, deep into the lungs, directly into the alveoli. Those are the tiny little air sacs where your actual oxygen exchange happens, and they physically lodge right there. But it gets worse. Because they are so deeply embedded, they actually cross over into the bloodstream, and that triggers massive systemic inflammation and severe cardiovascular issues. So it's not just a lung problem anymore. It literally becomes a heart problem. Okay. Now for the chemical side of things. Let me pose a question to the class. Why exactly does carbon monoxide kill? I mean, it doesn't physically scrape your lungs like particulate matter does, right? Well, it's a chemical culprit. It basically robs us of oxygen. When you inhale CO, it binds to the hemoglobin in your red blood cells so much more aggressively than oxygen ever could, and it forms this, carboxyhemoglobin. Think of it like this. It essentially locks the doors on your red blood cells, drastically reducing your blood's capacity to actually carry oxygen to your vital organs. You simply suffocate from the inside out, completely on a cellular level. Now, beyond particulates and carbon monoxide, you really must commit this crucial list of additional airborne threats to memory. First, nitrogen oxides, or NOx. These are absolutely notorious for exacerbating asthma and causing acute bronchitis. Then we have sulfur dioxide, SO2. Not only is this a major precursor to acid rain out in the environment, but it causes severe respiratory distress when you inhale it. And please, take special note of this last one, ozone, or O3. If you see ozone on your exam, remember it is uniquely classified as a secondary pollutant, meaning it isn't emitted directly from a car's tailpipe. It actually forms in the atmosphere through complex chemical reactions. And when you breathe that in, acute lung inflammation. Don't forget that one. All right, let's shift gears and move right into Module 3, Water Contaminants and Heavy Metals. So, we are shifting our focus from the gases we breathe up in the air down to the invisible, often completely tasteless, heavy metals hiding in the water we drink. This is where the biological disruption becomes incredibly profound. I actually want to pause right here and test the class before we reveal the answer. Think back to your historical case studies for a second. Does anyone know what devastating neurological condition is caused by chronic exposure to mercury, specifically methylmercury in the water supply? The answer is Minamata disease. Please mentally anchor the chemical symbol for mercury, Hg, to the real-world tragedy of Minamata disease. This occurred over in Japan when industrial wastewater heavily contaminated with mercury was just casually discharged into Minamata Bay. Well, that mercury bioaccumulated in the local fish, the surrounding population ate that fish, and the result was absolutely catastrophic. We're talking severe neurological damage, numbness, extreme muscle weakness, and total damage to vision and hearing. Connecting this real historical tragedy to the element makes the rote memorization for your exam emotionally resonant. You won't forget it now. Okay, get your pens ready because you absolutely need to know how to spell this next medical beast in your notes. Methemoglobinemia. Go ahead and write it down. Now, this condition is much more commonly known as blue baby syndrome, and it is directly linked to nitrate contamination in drinking water, which we often see coming from heavy agricultural runoff. When infants consume water that is high in nitrates, it completely interferes with their blood's ability to carry oxygen, which causes their skin to literally turn a bluish color. So nitrates equal blue baby syndrome. Lock that pairing into your brain right now. All right, consider this your ultimate cheat sheet for the heavy metals section of your exam. Take a moment to really scan these pairings. First up, cadmium, or CD, causes itai-itai disease. Fun or not so fun fact, itai-itai roughly translates to it hurts in Japanese, which perfectly, terribly describes the horrific bone softening and kidney failure the victims experienced. Second, arsenic exposure is the direct culprit behind Blackfoot disease, which is a really severe disease of the blood vessels. And finally, excess fluoride in drinking water leads to fluorosis. This causes the mottling of teeth and, in really severe cases, crippling skeletal deformities. So again, cadmium to itai-itai, arsenic to Blackfoot, fluoride to fluorosis. Got it? Excellent. All right, final stretch, everyone. Module 4, exam revision and conclusion. We have covered the absolute major atmospheric and aquatic culprits today. Now, seriously, take a mental screenshot of these key pairings because I guarantee you they are going to show up on the test. Let's recap them together rapidly. PM 2.5, physical damage to the alveoli causing cardiovascular issues. Carbon monoxide, chemical damage via carboxyhemoglobin causing reduced oxygen. Mercury, the neurological tragedy of Minamata. Cadmium, the bone softening of itai-itai, and nitrates, the oxygen deprivation of blue baby syndrome. If you can visually recall this exact sequence during your exam, you are going to completely dominate this section. So, we've successfully mapped the pollutants to their pathologies. You are 100% ready for the exam. But honestly, I have to leave you with one final vital question today. Now that you actually know the pathology of these pollutants, what is your role in addressing the biological warfare happening just outside this classroom? Passing the UGC NET exam is just a stepping stone, folks. This knowledge equips you to be informed citizens, to be policymakers, and to be future educators. So how are you going to use what you've learned today to actually help clean up the air we breathe and the water we drink? I really want you to think about that. All right, class dismissed. Keep studying, and I will see you in the next explainer.